Hi there and welcome to this video in the IBM Cloud Foundation Skills Series. So this video is all about auto-scaling in IBM Virtual Private Cloud. Now this is going to be a lecture, it's not going to be too long, but I'm just going to run you through what auto-scaling is and mention the different bits that you need to be aware of when you deploy auto-scaling for yourself in VPC in IBM Cloud. So first of all, what is auto-scaling and why is it actually useful? Well, basically, auto-scaling is a means to grow and shrink resources automatically. And this is quite important. Well, actually, it's very important, especially if you have a workload that experiences changeable demands on its capacity. So imagine you have a large retail website that specialises in gardening equipment. At the best of times, you'd hope that it's nice and busy, but you would also expect to have peaks and troughs in custom throughout the year. So for example, you'd expect spring and summer to be busier than the winter because spring and summer is when people are out enjoying their gardens and hopefully buying stuff to put in it, you know, maybe to mow the grass or spades to dig up their borders, that kind of thing. But there may be times, you know, such as a heat wave when people are suddenly buying lots of new barbecue equipment from you, you know, which means a higher than usual peak on top of your sort of, you know, highest peak in trading. And of course, there's also times when you have sales on, such as Black Friday, as well as the festive period, for example, you know, again, when you hope sales will go up and you hope that traffic will increase on your website. So how do you actually size your infrastructure for this changing capacity all the time? Well, in traditional environments, you tend to size for the peak and hope that that would be enough. But the trouble is you're then actually spending money on compute resources that you don't need all of the time, so that can get quite expensive. The other problem is that if you do have this changeable demand, you're still not quite sure if enough is going to be enough. So this really is where auto-scaling comes in and where it's a big winner. So basically you set yourself up so that you have enough resources to meet a normal level of demand, and then you set up the autoscaler to automatically deploy new servers when you actually need them, and then you scale them down when you don't. So let's kind of show that in this diagram. So here we're sort of showing a normal demand. So in this example, we have a web server in each of our three zones in our VPC, and we have one in each of our zones because we want it to be highly available. So this runs okay and it meets a normal level of demand. However, we might see traffic ramping up, and that means that this starts to struggle. So what the autoscaler will do is it will start to add more servers. So you can see another server has been added to London 1 because it needs it for the demand. So the autoscaler keeps checking, demand goes up again, so it creates another server for me in London 2. And then demand keeps going up on my website. Perhaps today is the start of my big sale. So the autoscaler's noticed this, and again, it's actually hit the peak now, and I've got 6 servers now instead of 3, 2 in each site. Okay, so then the traffic actually starts to fall away because maybe, you know, the peak of my sale time is over, people have spent their money. So now I'm running 6 servers and maybe I don't need the traffic anymore. So this is where the autoscaler starts to shut down the servers. So for instance, it will shut down the server in London 3. Maybe there's still enough demand to maintain 2 servers in London 1 and 2. But again, then demand falls a little bit more, so it stops another server. And then finally, demand gets back to sort of the normal thing, and I'm left with 3 servers again. So the autoscaler keeps an eye on what's happening in terms of the demand and adjusts the number of hosts that I actually have accordingly based on the rules that I've set up. So what do you actually need to run autoscaling? Well, first of all, you obviously need a VPC. Now that sounds basic, but remember you need to have your VPC set up and working properly before you start setting up autoscaling. And that includes things like making sure your networks are available, your ACLs have been created, and your security groups are created. And of course that your ACLs and your security groups are actually set up and configured properly as well. Next, you need to have a load balancer for the autoscaler. So when you set up the instance group, if you want new VSIs to automatically attach to a load balancer, the load balancer must already exist when you set the group up. Also, it must have a back-end pool created and a front-end listener as well. And importantly, it must not have any hosts already attached to it when you create the instance group as well. So there's other videos in this series which talk about creating a load balancer for VPC, so I'm not going to show that in the lab, but do remember that if you want to use an autoscaler with your autoscaling group, your instance group, you need to create it first. So once you have those two things in place, you then need to create your instance template and the instance group. So what are those? So in basic terms, the instance template describes what the VSI that the autoscaler creates actually looks like. So it includes things like the default name, vCPU and memory details, things like disk sizes, operating systems, that kind of thing. Now, you can also use user data to automatically configure the machine. So in the lab in the next video, I'll be using user data so that my new server automatically sets itself up as a web server. But you can also do things like import server templates if you have them, and actually use those as well to start your machines up. So that's the instance template. So what does the so basically, the instance template describes what the server looks like that you're building. Then we have the instance group. So an instance group is basically a group of virtual server instances that are actually under the control of the autoscaler. Now, when you create the group, you tell it which template or templates it should use to create new VSIs when they're needed. Hence, you need to create your instance template first. So remember, you can have multiple virtual machine types sitting within an instance group, so it doesn't have to be just one machine type. So you then state an autoscaler method, and this can be a static or automatic method. So with static, the autoscaler will maintain a certain number of servers for you. So if one dies for some reason, it will automatically build a new one for you. And then with automatic, the number of servers it maintains is based on rules that you set on current load. So that can be things like CPU usage, memory usage, and network traffic in and out. You also actually set up group sizes, so the minimum number of servers to maintain and a maximum number too. So remember that you need to pay for the resources that you use. So you can set up a maximum to make sure that you don't get a shock when you see in your bill that you've been running 150 VSIs because of an error in your autoscaler rule. So you can keep it in check that way as well. And then policies, and these are basically the rules as to when to increase and decrease the number of active servers. Okay, and that's really all there is to autoscaling. So it's really easy to implement, yet a really powerful tool in making sure you have enough virtual server instances and resources to keep your VPC application up and running and actually performing well based on the load that it's actually under. So in the next video, we're going to put this into practice and I'll show you how to set it all up, and we'll actually see it in action as well. But in the meantime, thanks very much for watching this video. As always, if you want to see when new content is added to this series, please feel free to subscribe. And in any case, hopefully I'll see you next time.